acoustics. Now let's talk about how it works. So sound travels in the form of waves. So in order to understand the physics of sound, we must first understand the physics of waves. The way that waves travel is called wave propagation or wave motion. So close your eyes and think of a wave and describe it. What in general would you say? The most common waves that come to mind are ocean waves. So now we need to define what is a wave. The world is full of waves. Can you think of some other waves except for ocean waves? Basically, sound travels as a wave, light travels as a wave, we have radio waves, and we have X-rays, and we have water waves, and so on and so forth. So all the space around us is constantly being crisscrossed by waves. There's not an inch of space on Earth that can be caused completely wave-free. If nothing else, light will always be present. So all communication, whether it be speaking, listening, seeing, depends on some wave of some kind. The type of wave may be different, but they are all waves nonetheless. 2 of our 5 basic senses are wave detectors, namely the ears and the eyes. The ear is an air pressure wave detector for sound waves, and the eyes are electromagnetic wave detectors for light waves. So in order to define what a wave is, we need to look at some properties of a wave. So all waves transport energy from one place to another. All waves transport information from one place to another. Some waves need a medium to transport this information. Note, the medium itself will not transport with the wave. So the definition of a wave is a transfer of energy without transfer of matter. One of a really good example by which energy is carried away by the waves is a seismic wave that are produced as a result of earthquakes. An earthquake is a seismic wave that travel away from the epicenter of focus of the earthquake. Seismic waves travel through the earth in form of body waves and along the earth crust in form of surface waves. So even though the fault movement is the cause of the earthquake, most earthquake damage is not caused by the fault movement of the earth, but rather it is caused by the motion of these seismic waves. The point is that the material through which these waves, which is the earth or the crust, is not transported. Only the energy is transported. And as soon as the wave passes through, the crust of the earth comes back to normal. So now let's talk about the different types of waves. There are basically 2 main categories that waves are divided into, longitudinal or transverse. Longitudinal waves are those waves in which the medium moves back and forth in the same direction as that of the motion of the wave. So for example, like this, a slinky is shown here, and the wave is moving back and forth along the direction of the medium. The transverse waves are what we mostly easily recognize as waves. In this, the motion of the medium is perpendicular to the motion of the wave. For example, ripples in water, vibration of a piano string. In a water wave, the actual water molecules move up and down while the wave moves horizontally. So as an example, this is going to be what a transverse wave looks like. One of the really good examples to see what a wave looks like is the people wave that people make in stadiums and in sporting arenas, in which the wave is going parallel, but the people are each moving up and down. So now let's talk about waves that combine transverse and longitudinal motion. So there are 4 different kinds of waves that I want to talk about today: seismic waves, ocean waves, guitar strings, and human waves. So in a seismic wave, there are 2 main kinds of waves: body waves and surface waves. Body waves are called primary waves, are further divided into primary wave and secondary waves. So P wave, or the primary wave, is a compressional wave. So as you can see, these are the directions of, assume that this is the crust of the surface of the earth. The wave is moving along the direction of the crust, right? S wave is also called a shear wave or secondary wave. In this case, the direction of propagation of the wave is along the same direction. However, the motion of the particles is up and down. This is the wave that actually causes all the destruction as it goes through. Ocean waves are a combination of two different kinds of waves. Waves that are formed deep underwater and waves that are formed on the surface. Underwater waves are mostly longitudinal. The waves that are formed on the surface have both longitudinal and transverse components. On the surface, the water molecules move in circular path as the wave passes. The air above the water presents little resistance, so the water swells up. This swelling water is then pushed down by the force of gravity of the earth. Near the shore, the crust collapses and the motion of the water gets more complicated, which we are not going to discuss here. Case 3 is guitar strings. So when a guitar string is plucked gently, it is a pure transverse wave. But when it is plucked with more force, it is a combination of transverse and longitudinal wave. And we will talk more about this in the upcoming chapters. The human wave in a typical stadium, a classic human wave has a phase velocity of about 20 seats per second. So all the people go up and down and the wave travels horizontally. Talking about different kinds of waves. So what are the differences between the various kinds of waves? So the similarities between each kind of waves is that all waves can be reflected, refracted, or diffracted. All waves have energy, and all waves transport energy from one place to another. The differences between the waves is that the different types of waves propagate with varying speeds. So the speeds of each wave is different. So light and radio waves travel at about 186,000 miles per second. Sound waves travel about 344 meters per second, and water waves travel a few feet per second. The other difference is that light and radio waves do not need a medium to travel through. Sound waves, on the other hand, require a medium like a solid, liquid, or gas for propagation. Without having a medium for it to propagate, sound will not travel.